influence people's responses? Do you think so? Eric randomly selected 100 people to one of two groups. He asked the first group, which Southwestern restaurant chain do you like better? Chain C or chain Q? He asked the second group, which Southwestern restaurant chain do you like better? Chain Q or chain C? So what he's doing is he's changing that order. Notice that he does C then Q, and then he does Q then C. So in the C first group, so this group right here, it says that 31 out of 50 said they preferred chain C. Like C. In the second group, where am I at? In the Q first group, 25 out of 50 people said they like C. So we can kind of look right here. We can make a guess that, if you say C first, that might influence people to choose that option. But it could also just be that chain C is better. We don't know if there's a significance difference to actually check this out. So researchers want to know if there's a difference in the proportion of people like these who would say they prefer chain C for the two versions of the survey question. State the appropriate hypothesis for performing a significance test, and be sure to define the parameters of interest. So let's go ahead and start with figuring out what we know. We're going to start by identifying what is P sub 1. So I kind of wrote it up here. So P sub 1 is the true proportion of people who chose C when asked C first. Now the second one, P sub 2, is going to be the same thing, but different. I finally figured out where that's from. You'll know how I've been saying that all year. You're like, where is it actually from? I don't think this is where it's from, but I tried to find a clip on YouTube to show you guys, and then, it was from the interview. And I didn't think that was a very good source to, put in the video. So if you want to check it out, it's from the interview where they go to North Korea to interview Kim Jong-un. I think, a very controversial show. Okay. Now the second group, they were given Q first, not C first. So I'm going to put a Q. I'm going to erase that completely and pick Q. And then that's a T with an I. Alright, so there's our P1 and P2. So let's figure out what those hypotheses are. So the null hypothesis is going to be that there is absolutely no difference. If you find the proportion of the first one, the true proportion of people who said C, when given C as an option first, is going to be no different than the other group. Now your alternative, this is the one that requires a glittery pen, apparently. This is the one that requires a bit of reading. So the first proportion minus the second proportion. So I kind of underlined it, but it says where there is a difference. So they don't know if it's going to be greater than or less than. They're just saying, you know what? There's going to be a difference. It's not going to be 0 if you subtract the two. We don't know if you're going to get a positive number or a negative number though, but it's not going to be 0. So that's going to be our alternative hypothesis, and those are easier to find, which is why so many people prefer that to happen. So let's go ahead. So that's your state. Yes, we're missing some steps on the state, and that's okay. Let's move on to plan. Okay, so we're going to check those conditions. Okay, so the first condition. Is it random? So right here it says randomly assigned. So yeah. So the second thing that we need to do is figure out why that happened. Just kidding. So it's n sub 1 times p sub 1 greater than or equal to 10. Let's figure this out. So n sub 1, our sample size for the first group. If you look right here where I wrote it, this number right here is your sample size. So n sub 1 equals 50. Your sample proportion, p hat, is 31 over 50. N sub 2 is also 50. Hey. P hat sub 2 is 25 over 50. So let's go ahead and check it out. So 50 times 31 over 50. Is that greater than or equal to 10? Oh, look, cross multiply. 31 is greater than or equal to 10. Yes. Okay. N sub 1 times 1 minus p sub 1. And if you're wondering, like, why do we do this step? The reason why we do this step is this is trying to say, are there at least 10% of people who agreed and 10% of people who didn't agree? That's why it's 10, because you need 10% of the population. So your sample has to have at least 10% of those guys. So we're going to do 50 times 1 minus 31 over 50. Is that greater than or equal to 10? So remember, 50 times 31 is 19. 19 is indeed greater than or equal to 10, so this is good. So step 2, rocks. Boom. Condition number 3, n times 2 times p sub 2 greater than or equal to 10 hat. So 50 times 25 over 50 needs to be greater than or equal to 10. Cross it out. 25 is greater than or equal to 10. Boom! Yes, that's correct. N sub 2 times 1 minus p hat sub 2 needs to be greater than or equal to 10. So 50 times 1 minus 25 over 50 greater than or equal to 10. And 25 is greater than or equal to 10. So yes. The conditions are met, and if we say that it is approximately normal, by the large counts condition, large, I should make that a actual L, counts condition. Alright, so you guys have 2 problems to go try out on the Google Classroom. Give it a go, answer all the questions. I turned it into like a quiz thing, so that way whenever everyone is done answering it, y'all can actually see what you got right and what you got wrong. But that's not going to happen until everyone's done answering it. So encourage your friends to do it, so that way you can see, are you right, are you wrong? If you have any questions, email me. Send me a message through Remind 101. If you send me a message at an unreasonable time, I'm not answering. Sorry. But if you need me, I'm here. Stay safe, stay well. See you in the next video.